we're going to have a direct connection to the hypothalamus, which is going to have its connection between the brainstem and my cerebrum. Ever known anyone that might have had like pituitary gland problems? Actual pituitary gland. Not something like thyroid gland or something like that. Like for example, a tumor on their pituitary gland. My sister does. The problem with that, it's going to affect every hormone. Every hormone. And the other problem, not a lot they can do about it. It's not like they can go in, remove the tumor, because if they did, the surgery for that is horrible. They have to go through the mouth, up through the palate, back behind the nose. It's very bad surgery. Yeah. Every hormone in her body is affected from that tumor. Now, to give you a new perspective on this connection between nervous system, endocrine system. So if I look at this area, I found some really cool stuff. Thalamus. What did we say the thalamus does? My relay center. So, information on those ascending tracks gets sent to the thalamus. The thalamus then says, oh, wait a minute, you need to go to frontal, parietal, blah, blah, blah. That's likely it's going to go part to the gyri. But we're going to get to that. Subthalamus, epithalamus, hypothalamus. The names are letting you know where it's kind of located in relationship to the thalamus. That is my diencephalon. Huh. Let's look at that. They're trying to represent in these different colors the areas, okay? Because the hypothalamus, and then if we look at that, we're having a connection to my pituitary gland. We're also seeing all of these other connections, and they're trying to show you all these different areas located within that diencephalon. So if we think about the subthalamus, if we think about epithalamus, if we think about all these areas, thalamus here, everything else is letting you know the relationship to it. Note that it's not really, not a very well defined area. But one thing that we can see that it's inferior to is that corpus callosum.
Is that a particular reason that the pituitary gland is segregated from the rest of the brain?
Yes. Because we're going to have, when we look at that pituitary gland, and you've got that anterior and the posterior portion, the anterior portion is going to have this really cool vascular connection to the hypothalamus, and the posterior is going to have a nerve connection. And they're running by way of these canals. Really cool. But that corpus callosum, do you happen to remember what I said that was? Alicia? What's it made up of? Nerve, what part of the nerve? Axon. When I say that this corpus callosum, and remember, between the two halves, so that the two halves of the brain can communicate, all right? That corpus callosum, being this bundle of nerve fibers, when you dissect the brain and you try to cut through that, it is so tough that it requires lots of pressure, a very sharp scalpel, okay, and possibly even other tools for my connection between the two halves. And now I've got a connection controlling my endocrine system.
That's the bridge between the left and the right side of the brain.
Bridge between the left and the right side. How they're going to talk to each other. Another view, thalamus, hypothalamus. Do not lose this visual, because we're going to come back to that. All right, where it looks like it's this W. All right, and then my pituitary gland sending off of it. Don't lose that visual. For the thalamus, once again, my relay center. We're going to see that it's connected because we've got left and right. Do you guys remember the third ventricle? What was the third what were the ventricles known for? My cerebrospinal fluid. So I now have it being surrounded by the third ventricle. My relay station. It's the area where sensory, all of this, okay, from the spinal cord synapses, and then gets sent to the area of the cerebrum where it needs to go. Nucleus. I have 1, 2, 3 nuclei. Nuclei are what? Until everybody, I'm going to ask y'all this until everybody says it. Areas of dense nerve cell bodies. Okay? 1, 2, 3. Medial, lateral, ventral. For my thalamus. They get to send information somewhere. One of those nuclei, strictly for auditory. Which is what? My hearing. Which I'm finding must not be so great. got a phone call this morning. All the way back here on the 3rd row, they got to hear the phone call because I got the volume turned all the way up. Because I just can't hear it. But stop and think about this for a second. How much noise is going on around you every second of every minute, of every hour, of every day? That was good timing. Good example. Electricity goes out. Well, you know, maybe a storm comes through and knocks it out. What do you know? It's like, I can hear. Because everything around us has got noise. Everything. Light. We're surrounded by it. One of them, visual. Okay.
Just a question about the auditory information. Does this have anything to do with the phenomenon where they say like silence is deafening? When you sit and there is no sound and you don't hear something, but you feel like you do? I don't know, it's hard to explain.
Oh, where they're talking about like people hear their cell phones ringing and they're really not.
Well, when I sit in a room and there's no sound, I get this like, and I know it's not like hearing because if I do other things, if I make noises, I hear them clearly.
Mm-hmm.
But like I get this sensation of this screeching, whistling in my ears.
Well, yeah, believe it or not, that's from the damage of all the noise that surround us, and like Brian just said, tinnitus. Okay. I think as we get older, because we're so accustomed to so much noise coming into us, that is a constant moving of those hairs for sound, and they get damaged. And I think that when we do have pure silence, because of that and they're damaged, it makes us think. It makes us feel like we're hearing something, this background noise, just whatever it might be. Yeah.
Like even as I know there's like certain frequencies you lose the ability to hear.
Yeah.
Like where a dog can hear the dog whistle. I know as you get older, there's certain sounds, especially like on the higher end of it.
You just can't hear anymore.
You can play a video on YouTube and probably most of the younger people in this class will hear the sound, but people that are in their late 20s or older will hear it because.
Imagine it at night. All right, I mean, I'm going, what? Because y'all see me do that in class. What? And I do that because, believe it or not, that actually helps to funnel sound into your ears. But I'm just surprised that for two of our special senses, we've got nuclei dedicated just for them. Two. The ventral taking care of the rest. So this thalamus is making sure that signals coming in get sent to the area of the brain that can process them for information and give us a response back. Now, other types of information that's coming through: motor function, mood modification, emotion regulation, sensory integration. Some are going to these other nuclei to these nuclei that are present. The thalamus is rather busy, to say the least.